First thing we're going to do to make our offset flywheel is create a new document. It comes up and asks me, do I want to make a part or an assembly? I want to make a single part. As with most Solidworks projects, we're going to start with an extrude to give us something from which we can build other things. I'm going to go ahead and choose the top plane to draw my sketch, and I'm going to start by making the circle that's going to represent the outer diameter of the motor shaft. Use your calipers and measure that. I'm looking at it right now, less than 1/10 of an inch. We'll say it's 0.07. Oh, that's very small. So I'm going to scroll down to zoom in on this, and I know that this represents the inside diameter of my flywheel. I'm going to use a feature called offset entities. If I click that and then select something, it will create an offset reproduction of what I've selected a certain distance away. I know that 0.1 inches is plenty of plastic to make this offset flywheel strong, pretty much no matter what I put on the other side. I'm going to go ahead and complete my offset flywheel design with a relatively boring, simple shape. When you're doing yours, please experiment with the draw tools and make this unique and cool. Otherwise, all of our flywheels look the same, and they really are. There's opportunity for you to be creative here. I don't know what you want to do, but you have all sorts of draw tools. Experiment with the drop-down menus. This is a cool tool with a spline. Once you finally have something that you like, you need to exit your sketch, and it'll automatically take you to the rest of the extrude menu, which just says how far do you want to extrude it. 0.4 I've found is plenty. This is really not a critical dimension, so you notice I'm dragging it up in here. I could have just typed that value. Once I hit the checkbox, I've got my shape created. That should fit around the motor shaft just fine, and as it spins, it'll create vibration for the system. When we're saving this, we need to save it as an SLDPRT. That's the Solidworks part. That means we can open up the file and access the history of everything we've done. And once we've saved that, then we go back through and hit Save As and change the file type down to an STL, stereolithographic file, I believe. You'll see it turns the outer shell into a series of triangles, which the 3D printers use. Once you've finished your offset flywheel, time to make the advancer. Go ahead and make a new part. Jump in and let's make an extrusion first. I'll do the top plane. And let's set a dimension on our advancer to be 3 inches looks good. So we'll hit OK. So in the solution, you saw the circle that had the notches cut out and it rotated, advancing one skittle at a time. The way that those notches were made is one was made and then it was patterned around the outside edge. That's what's the skill I want you to learn here. So I'm going to make a really basic shape, and I'm going to put a circle that is centered at the top, and that looks pretty good. You should definitely use smart dimensions and give this thing dimensions based on what you measure from the skittle. Use the trim tool. I'm going to cut this out and I have a really nice little notch here. So the way that you pattern this around is we're going to jump into this pattern feature here. There's a linear sketch pattern, and if you hit the drop down menu, there's a circular sketch pattern. The way it works is you tell it what feature you want to pattern and then in what direction, and it creates a whole series. And this works for either sketches or features. I'll hit this one. And the first thing it's asking me is what's the parameter about which I'd like this thing to rotate. So I'll click this guy, and it automatically assumes that I want to put it around, and it's right. You can adjust how many notches you want, and again, that will be up to your group. I'll leave 4, and just like that, I've patterned that feature around the outside edge of the circle. I'll use the trim tool to cut out the rest of the notches, and there we go. I'll go ahead then and exit my sketch. Now I'm extruding. Again, 0.4 is fine for our purpose. The next cool feature I wanted you to see is the shell feature. The shell feature is going to help us out a lot when we want to save plastic. So the printing takes hours, and if we can eliminate plastic that we don't need, it's going to save us a lot of time. So the first thing it asks me in the shell is what face do I want to remove? And the best way to demonstrate what this tool is to show the preview. What it's going to do is it's going to leave a wall thickness of whatever I select there, 0.1 is fine, and remove all the inside plastic. I didn't do this on the offset flywheel, and we didn't do it because we want the offset flywheel to have a lot of mass. This one, we want it to print quickly and still be strong enough to do its job. We're only moving skittles, so that's plenty strong. Last thing we need to do is cut a hole in the middle of this device for the servo horn screw. This is not a critical dimension, so I'll just go ahead and cut through everything, and here we have it. You will need to save this as both a SolidWorks part first, and then make it an STL if you'd like it to be printed. The last thing you'll need to do after this is to design your own chute. So that's the part that the sorter turns to determine what bin the skittles go into. The skills that you've developed in the offset flywheel and the creation of the advancer are skills enough to create the chute. So you're going to need to figure that one out on your own. I recommend making a sketch in your notebook and thinking about it for a while and then approaching the computer. Best of luck.